Hello and welcome. In this video, we basically find the photocurrent of black phosphorus using Nanodcal software. I am Ujjwal Pratap Singh, an application engineer from Impulse Technology. Let's jump to the device studio and design the structure of black phosphorus and find the photocurrent. Let's move to the device studio. Open the device studio. Click on create a new project. Click on OK. Give the name DP means black phosphorus and click on save. In the project section, you can see Photocurrent 3P. This is a device studio UI where you create your black phosphorus structure and create a device. This is a toolbar, menu bar. In property section, you can see the property of your material file. And in job manager, you can see the description of your input file. This is in running condition or in queue condition. Let's import the black phosphorus first. Go to the file option, then import local, importing material, novelty material. You can see black phosphorus. Click on open. Go to the build option to redefine. Click on redefine crystal and in C direction, increase the length by 10 and click on view. You can see, click on build. Here you can see convert to device option. Click on this. Click on left electrode, right electrode. If you want to change, you can also change. Click on preview and click on build option. After that, go to the simulator option, Nanodcal, and go to the self-consistent field calculation. Here you can see K-point sampling, exchange correlation, go for the GGA, and in control integral, go with the default parameters. Electrode, if you want to electrode voltage, you can add electrode voltage also. I go with the 0 option. Iteration control, you can see. Basis set spin type, go with the no spin disk type and click on generate file. You can see it created a folder with name device, left electrode, right electrode. In left electrode, you can see SCF input file. You can also see the script of SCF input of left electrode. If you want to change something, you can also change in the script. After changing in the script, you can click on the save option. First, you have to run the left electrode SCF input file. Right click on run. In the same way for the right electrode, after the left electrode SCF input file, click on right electrode SCF input file, right click on run, then go for the device SCF input file, right click and click on run. In the job manager, you can see left electrode SCF input file in running condition. After that, right electrode SCF input file in queue condition. In the same way for the device SCF input file in queue condition. Again, go to the simulator, Nanodcal, analysis, and your electrode type will be device and go to the photocurrent option. You can see photocurrent parameters like polarization basis, polarization vector, linear polarization, left circular polarization, elliptical polarization. Let's go for the linear this time and click on edit irradiated data and select all. Left click of the mouse and drag the box and click on select, then OK and click on generate file. You can see it create photocurrent input file. From photocurrent input file, you can see photon polarization basis, photon polarization angle, photon energy range, energy interval. Let's decrease the irradiated atom because it will take time. Go with 1 to 24 only. And in here participants can also change 25 to 32 and 33 to 40 and click on save. Close this window, go with photocurrent input file, right click and you click on run option. In the job manager, we can revise SF input in running condition and photocurrent input file in new condition. Here you can see the result of photocurrent at photocurrent, right click, click on show view. You can see photocurrent for black phosphorus. For lead 1, you can see normal light photodiodes versus photon polarization angle. This is one for lead 1, go for lead 2 also, and go for Hall for lead 1 and lead 2. According to your data, you can also change in value control. If you want to save, you can also save the photocurrent file by clicking on the export option. You can save in multiple image format and text format also and click on save. If you want to see the data of photocurrent mat file, you have to switch to the MATLAB and upload your project here. By clicking on this, my project in D folder, photocurrent, like phosphorus, select folder, photocurrent, device, and device or photocurrent material file equal. You can see photocurrent XML file, photocurrent mat file, and psc.input file. By double clicking on photocurrent mat file, it load the photocurrent mat file in command window. Type data to see the photocurrent parameters and their value. You can see photon energy, photon polarization basis, photon polarization angle data. To go inside the data dot photocurrent, click on. You can see the data also. If you want to plot your photocurrent here, you can also do by typing Nanodcal. Plot photocurrent mat file. Plot the photocurrent to the photocurrent mat file in MATLAB to the command line of Nanodcal. You can see photocurrent lead 1 and photocurrent lead 2. I hope this video is helpful for you. If you have any doubt, ask in comment box or you can also mail to the support at ratinfirst technology.in. Thank you everyone. See you in the next video.